Hello and welcome back. You are used to me talking with a green screen, having nice PNP things, but today we are going to go back into time to this old whiteboard method, and we are talking a little bit about chemistry and how we observe in astrophysics, even though I'm not an observer. So if I make a little bit of blunder and you see it, please let me know. This is Monterey. Welcome to your cosmic kingdom. First things first, what is the universe made of? So, during the Big Bang, we only had hydrogen, helium, and lithium. And this has one proton, this has two protons, and this has three protons. And because matter is neutral, they also have one electron, two electrons, and three electrons. So, but you were wondering now, what are we made of? Yes, we are made of a little bit of hydrogen, but practically no helium and lithium. There is carbon, there is oxygen, there is nitrogen, there are metals, and if during the Big Bang only these three were generated, where are the rest of elements coming from? Well, it's basically they come from nuclear synthesis in the interiors of the stars that eventually explode as supernova. So what is the chemical composition of the universe? So basically hydrogen adds to 70%, helium 25%, and the rest of this would be at 2% is made by all the other elements in the universe that we in astrophysics call metals. So how do we know this? Well, we know this because of observations, because this composition does not hold on Earth. Actually, helium is very rare here on Earth, and it's really expensive. But we are able to observe this by using quantum mechanics. So why is that? How do we manage to get this? Imagine that you have a nucleus here with a lot of protons, neutrons, stuff. And this is a neutral atom, so we'll have different layers of electrons orbiting around. If one electron from here gets promoted to this external orbit, or so quantum orbits, but it's just follow me on the analogy, it will gain energy. So when the electron is tired of being here and goes back to its state, what it does, it emits a photon, something that we can see. This photon carries away the excess of energy that the electron acquired by coming here. The way this electron came from here to here could be by an atom collision. This atom collides with this one, and then one of the electrons carries away the energy from the kinetic energy of the atoms, carries away, gets promoted to a state, stays there for a while, and then re-emits the energy back into the shape of photon. What it is cool about quantum dynamics is that each line, each atom has a signature. And I'm going to use here the only moment that I'm going to edit this video, because you will see what we call a spectrum. And a spectrum is like a barcode, if you want, from the atom. So we know that when we observe the spectrum, we see this barcode, and then we, by just looking at the crests and the dips, we are able to infer which atom we are observing. And there are more cool things that we can do with the spectra, but I will reserve this for a future episode. So, what happens to our initial composition here? Helium. I'm going to start with helium. Helium has two protons, and then its last orbit is filled with two electrons. It's an inert gas. The two electrons are there happy as a clam, and they don't want to move, and they require a lot of energy to produce some observable lines. But with hydrogen, the story is different, because hydrogen is only one proton and one electron. And there are different ways of observing it. The one that I like the most is the 21 centimeters. What is that? It's because the nucleus is spinning in one direction, and the electron is spinning, can be spinning parallel or in opposition. And this difference in energy creates a photon who has a wavelength, which is a color that is 21 centimeters long, and this is a radio wave. So we can observe it with this massive antenna that we see in the movies and in the pictures. Another cool thing is that, as I said before, this electron can be promoted to a different level, and we call it as a Lyman series. And this will give us a line that is called Lyman alpha and fields on the UV. It's really energetic and can be observed in the ultraviolet, well, visible telescopes or telescopes in the ultraviolet. As you all know, or you should know by now, that I'm very interested in molecular clouds. And molecular clouds are based off molecular hydrogen. And the problem with that is that it's very, very, very difficult to observe. I will leave that for another episode if you want, but just believe me, where it's very difficult to observe. So what astronomers do is observe CO, carbon monoxide, which is highly toxic and we don't want here on Earth, but we love there in molecular clouds. This one has like a nice that we can measure, and with that barcode we can estimate the amount of CO in one molecular cloud out there, and with that estimation we can calculate the amount of molecular hydrogen. And this is crucial because we need to understand that to understand how stars are formed. But again, I will leave that for another episode. I hope you like this all. If you really like it, I will be very happy to do more with this. If you don't, just let me know. But it's a pleasure to be with you every single week. Bye bye guys, and see you next week. Hydrogen